Hey class, I wanted to just start the week off here with a 5.1a review. So just doing some problems from the section that we started last week. So the first one I'm going to do is y equals 2x to the fourth minus 11x squared plus 9. So the first thing I want to do is list all the possible solutions. So remember, it's all the factors of the constant divided by the factors of the leading coefficient. So my potential solutions would be factors of 9 would be 1, 3, or 9, and both positive and negative. And factors of 2 would be 1 and 2. So my solutions, my possible solutions would be 1, 3, 9, or 1/2 if you divide the 1 by the 2. So a possible solution would be 1/2, or 3/2, 3 divided by the 2, or 9/2. And then to narrow down the list of possible solutions, we're going to plug this into our graphing calculator. You can use this calculator if you go under y equals, but it's a little bit trickier to use. So I'm going to actually use Desmos because it's just so easy to use Desmos. So y equals will be x to the fourth power. Oh, I forgot the 2. 2x to the fourth power minus 11x squared plus 9. All right. And it looks like I am given a few values here, but the Desmos, so to get those values, I tapped on the graph, and then I'm looking at just the x-intercepts. So I get rid of this, I can zoom in a little bit. So tap on the graph, and then those gray dots were the x-intercepts. So these are the ones that I want. Now, negative 2.121, that is an irrational root, most likely, so I'm not going to want to use that one to start, but I can start with either of the rational roots, which would be -1 or +1. So it looks like I have all my roots are real because I have 4 total solutions because it's a quartic function. So I'm going to start with using my x equals 1. Now I'm going to plug that in using synthetic substitution. So listing the coefficients in order, so 2, I'm going to have to put a 0 in because I have no x cubed term, then -11, and then another 0 for the x spot, and then 9. And then drop mama, so drop down the 2, and then multiply. The 1 times 2 is 2, add 0 plus 2 is 2. Multiply, 1 times 2 is 2, add -11 plus 2 is -9. 1 times -9 is -9. Add, you get -9 again, multiply, and then add. If in fact this is an x-intercept, which it is because I can see on the graph, when you plug it in for synthetic substitution, you should get 0 as your remainder. There should be no remainder because it is a solution. It should factor into it evenly. So then from here we have, it was quartic, so now this is a cubic function, 2x cubed plus 2x squared minus 9x minus 9. Now it does look like I'm able to factor by grouping from here. So factor by grouping, and that's not always the case, but this one I can. So I'm going to take out a 2x squared from my first group, and I'm going to be left with an x plus 1 if you divide both of these by 2x squared. And then to get an x plus 1 in the next set, I'm going to take out a -9, and I'm going to get an x plus 1 there as well. And then I get 2x squared minus 9 if I take out the x plus 1. Sorry, I'm jumping around a little bit. Take out the x plus 1 from each of these factors, and you're left with a 2x squared minus 9. Then finish solving from there. So x plus 1 equals 0, or 2x squared minus 9 equals 0. So here we're going to get x equals -1, and then 2x squared minus 9 equals 0. Add 9. 2x squared equals 9, divide by 2, okay, x squared equals 9/2, And then we're going to have to square root both sides. So square root a fraction, you square root the top and the bottom separately. It's going to give you plus or minus the square root of 9 is 3, and the square root of 2 is irrational, square root of 2. So that's our decimal that we're getting. Now, technically, we'd want this to be in rationalized form, so you'd have to multiply by the square root of 2 on both the top and bottom here to rationalize it. So the final answer would be plus or minus 3 square roots of 2 over 2. That's in rationalized denominator form. Square root of 3 divided by the square root of 2 and 3 square roots of 2 over 2 are equivalent. The one in green is just the rationalized form, which is technically more correct in algebra. So your 4 answers then was we had x equals positive 1, x equals negative 1, and then 3 square roots of 2 over 2, and negative 3 square roots of 2 over 2. So those are our 4 answers for that one. Okay. Now, before I go on, since I did have another root here, when I graphed this, I had 1 and negative 1 as a choice. So let's say that it didn't factor by grouping. So I could have stopped right here, and I could synthetically divide again by my x equals negative 1. I knew that x equals negative 1 was a solution. So I'm going to take that cubic function, the 2x cubed, 2x squared, negative 9x, and negative 9, and I'm going to plug in the negative 1. So I'm going to drop down the 2, multiply negative 1 and 2 is negative 2, add, I get 0, multiply, I get 0, add negative 9, negative 1 times negative 9 is 9, negative 9 plus 9 is 0. Since I went from a cubic function this time, this was this function, cubic, this would be an x squared, and this would be an x. So then I get 2x squared minus 9, and then I'm back down to this step where I could just solve that for x. So that's another option when you're given 2 rational roots, you're able to plug it in twice for synthetic substitution. And you just go down 1 degree each time. It started as quartic, then you plug in 1 root, you get to cubic. Then you plug in the second root, now you're down to quadratic. Quadratic you can solve using square roots or quadratic formula. It just happened that this one was able to be solved with factor by grouping as well. All right. The next one I'm going to do is y equals 8x cubed plus 1. Now, I chose this one because it might remind you of a cubed plus b cubed, where it's 2x cubed and 1 cubed. So I know that it would factor to 2x plus 1, a plus b, and then a squared minus ab plus b squared. So it would factor to 2x squared would be 4x squared, minus 2x plus 1 would be minus 2x, and then 1 squared would be 1. So I know that it would factor to this, which means that I know one answer would be negative 1/2 if I was to solve this piece. And then I could get my other answer by doing the quadratic formula for here. So that's what we did in the last unit. I'm going to solve this using the rational roots theorem. I know that all my possible roots are going to be the roots are the factors of 1, so plus and minus 1, divided by the factors of 8, so 1, 2, 4, and 8. So 1, 1/2, 1/4, 1/8 are all my possible roots. Let's take a look at what that looks like in Desmos. So y equals 8x to the 3rd power, and then plus 1. And then I can see I have one real root, and then it doesn't cross anywhere else. So that means that my other 2 roots here are imaginary. So 2 imaginary roots and 1 real root, because I should have a total of 3 roots. So my first real root was the negative 0.5, which was the half. So x equals negative 1/2. which I would have got solving it this way too. So I'm going to plug that in, -1/2, into synthetic substitution. So 8, I have to plug in a 0 for the x squared spot, a 0 for the x spot, and then the 1 is the constant. Drop mama. So drop down the 8, multiply by -1/2, you get -4. Add 0 and -4 is -4. Multiply by -1/2, you get +2. 0 plus 2 is 2. And then multiply 2 by -1/2 is -1, and you get 0. And then this, it went from cubic, it was an x cubed, so this is going to be x squared, x, and then my constant term. So now I have 8x squared minus 4x plus 2 equals 0. If you're hearing those toots, it's not me, it's the baby, I promise. She is filling her pants right here, aren't you? Aren't you? So don't worry, it's not me. So you might be wondering why it's not the same as what I highlighted up here in green, 4x squared minus 2x plus 1. But really, if you think about it, 8, 4, and 2 are all divisible by 2. So before you do the quadratic formula here, you might want to divide by everything by 2. So you get 4x squared minus 2x plus 1 equals 0. And then unfortunately, this one does not factor any further. So you'd have to do the quadratic formula. So you'd have A, B, and C. So x equals -b plus and minus the square root b squared minus 4ac all over 2 times a. So 2 times 4. So -2 to -2 is 2, plus or minus the square root. That'd be, in here, it'd be 4 minus 16. 4 minus 16 would be -12. And then 2 times 4 is 8 there. Hoofda Ava. All right. Square root of -12 can be simplified because it's 4 times 3 and 2 times 2. So I would get down to 2 plus and minus 2i, since it was negative, square roots of 3, all over 8. And then I can simplify that one more time and put my answer up here. They're all the coefficients. 2, 2, and 8 are all divisible by 2. So 1 plus or minus 1i square roots of 3 all over 4 would be my 2 imaginary answers. And my one real answer for that was -1/2. Okay, I'm just going to do one more here. The last one I'm going to do is y equals 3x to the 3rd power plus 11x squared plus 5x. So this time my constant term is 0 at the end. So all the factors of my constant would be 0 over all the factors of my leading coefficient would be 1 and 3. So it's telling me that 0 is my only possible solution. So my only possible solution for this one is x equals 0 because my constant is 0. So let's look at what this looks like in Desmos. So y equals 3x to the 3rd plus 11x squared. Oops. Squared plus 5x. Okay, so this is cubic. I must have entered something wrong because that doesn't look cubic. Oops, undo that. Okay, let's zoom out a little bit. Oh, there we go. I was only seeing the one parabola, and I was like, that's not cubic because that would be quadratic or quartic. Okay, so I have all of my roots are real, but 2 of them are irrational, so there's like square roots. But I do have that 0 is my rational root. So I knew that based on my rational root theorem that 0 is my only possible one. So without even graphing it, I could have just jumped to, I have to do 0 as my first choice, or my root. So plugging 0 in, you get 3, 11, 5, and then the 0 as the placeholder for the constant. So then drop down the 3, and multiply by 0, add, multiply by 0, add, multiply by 0, add. So I guess that was pretty easy to do that one. So, but it brings it down a degree. So plugging in 0, I'm dividing everything by a single x, essentially. You're factoring out an x, if you could think about it like that. You have an x equals 0, so you take out an x, you're going to get 3x squared plus 11x plus 5. So 3x squared plus 11x plus 5. I'm going to have to use quadratic formula again to solve that. So x equals negative b would be negative 11 plus or minus b squared, so 11 squared minus 4 times a times c all over 2 times 3. So negative 11 plus or minus the square root. 11 squared is 121. 4 times 3 is 12 times 5 is 60. 121 minus 60 would be 61. 2 times 3 is 6. And I believe that is as far as you can go. I'm pretty positive that 61 is prime, so I can't factor it down any further. So these are my other two answers. So if you go back to like a calculator and you were to type in negative 11 plus the square root of 61, and then that number, let's see if I can put this, divided by 6, you're going to get negative 0.53. And I bet this negative 0.532, that would be that first x-intercept. And then if you did negative 11, hi Mia, do you have a good nap?
Yeah.
Negative 11 minus the square root of 61, and you put that over 6, that would be the other root right here, the negative 3.135. So that's the exact answer for those two decimal roots that we found. All right, I'm going to do this in class on Monday, but if you're not with me on Monday, then here is some extra review for you. And then there'll be a short exit ticket quiz on this section. So